Hi, everybody. So my name is Stuart Reid, and I'm the CEO and founder of Nosible. And we are a vertical search engine that has been built for the financial services sector. My background is I'm a quant and a computer scientist, and I've spent some of my career working at banks where I was contributing to risk models that their job is to look at what's happening and basically make predictions about what's going to happen next. I also worked at hedge funds where I was developing deep learning trading strategies that were looking at information about global equities and, again, trying to predict what happens next. And one of the things that I learned while I was in that space is that information is actually usually not the constraint, attention is. And I think you'll understand what I mean after the next few slides. So while I was running this hedge fund, it was actually an AI-based hedge fund, and this is an event that happened in 2017. A company that's quite large called Steinhoff International collapsed 85% in a matter of days, right? And our fund actually just happened to not have a position in that, and it was picked up in the media, and people were talking about how AI avoided the Steinhoff collapse, right? I knew to myself, though, that it was mostly just dumb luck, as many things in finance are, but it kind of got me wondering, like, could we actually have known that that event was happening? And as it turns out, we could have, in some cases years prior. There's actually information that are written about these events, and the problem is that no one pays attention to them. And it happens over and over again, right? Right here in, closer to San Francisco, I guess, is, Theranos, like a good example of like an instance where there was actually many kind of like early warning signs that were being written about, published in the public domain that no one was paying attention to. The same story again repeats for Wirecard, right? Very large company that was in the DAX 30 at the time, again, collapsed in a matter of days and created billions of dollars of losses. And again, there was ample evidence, in this case, almost a decade's worth of evidence that this was a company that was pretty unscrupulous in what they were doing. One last example is China Evergrande. So in this case, it was not fraud, right? But it was actually just risk. And there was, again, a ton of evidence that this was actually, an unsustainable kind of situation that this company had got themselves into. So again, going back, it's like, the information is actually not the constraint. The constraint is our ability to pay attention to all of that information all the time. And our vision for the future is where AI actually does pay attention to everything that is happening all of the time in this, in the financial markets, right? And not only could we pay attention to these events, but we could actually start to unpack them and understand them and understand which events co-occur with those events and what it means, like, going forward. Right? And that is exactly what we're trying to build. We're trying to build the system that is monitoring everything that's happening with all these companies, trying to understand that, trying to correlate it to other events that have happened to companies in the past and work out what's going to happen next, right? So this is the idea that we've had for quite a long time. And our biggest issue, though, is that, search engines pretty much suck at doing this, right? We tried to build this off of, Bing a while back. We've tried other, alternative search engines as well. And just generally speaking, the scale of the operations that we would like to be able to do just don't match with how search engines are built. So to kind of drive home that point, let's say we're indexing the web, we're searching it 24/7, 365, and we're attending to every single result. There are 150 material events that we've identified that are, potentially relevant to some trading strategy that we've developed, and there's 150,000 companies that we want to track, right? So if you had to take 150,000 times by 150 and do all of those searches every single day, because you don't know when an event is going to happen at any given company, you would end up spending something like $3.4 million a month, right, in SERP costs. So this is the challenge that we have, is like we would like to be able to monitor everything all the time. We think that AI is now capable of actually doing that, but the search infrastructure is just not there, right? So this is a tech talk, so I promise for the next 5 minutes, it's going to get very technical. But this is actually how we have gone about solving this problem. So what we do is we sample very, very large portions of the internet. Our index now contains billions of web pages and many, many billions of vectors. And what we do is we build a system for generating edges, right? And the idea here is that we can encode a tremendous amount of information into an edge in a network, right? We can encode the fact that, two documents are semantically similar, they're lexically similar, they re-rank well together. The LLM agrees that these are two, similar documents. And if you can put that into a graph, what you can use deep learning to do is actually translate that graph into embeddings, and then take those embeddings and produce collections, right? So these are collections of documents that are semantically similar, lexically similar. They are about the same entities. They re-rank well together, and they contain the kind of information that we're interested in. And then what we do is we are continuously crawling the web, and we're basically streaming data into these collections, right? And that's where, Bright Data kind of comes in. I think we do about 15 to 20 million web pages a day currently, and every single one of those requests is actually routed through Bright Data. Let's go to the next slide. So once we have that, what we end up with is these collections of documents that are all very similar to one another. And what we would like to do is, given your query, given the thing that you're interested in tracking, whether it's a cyber breach or it's a layoff or any of those things for any of the companies, what we need to do is route that query to the most relevant collections that are the most likely to contain the information that we're looking for. So how we do that is we use, representations. We have sparse representations for each collection. We have dense representations, and we process your queries kind of in the same way, and we work out which of these collections are the most likely to contain that information. And then what we can do is we can continuously search those collections for any events that kind of match the criteria that you put into the system. A few things to mention here is that this is, the graph embedding representation that we had previously doesn't translate particularly well into routing queries in, because you don't give us a node in a graph. But what we can do is we can give all of that text to an LLM, and we can say, hey, tell us what this thing is about. And then we can actually generate representations off of the descriptions that are created by, that are written by these large language models. So that's just a helpful suggestion. And then once we route to the queries, to the collections that are most likely to contain the information, then it's a matter of processing that, pulling in all of that data, and continuously monitoring it. So as I mentioned previously, one of the big challenges that we've had has been, the cost of actually doing this in a traditional kind of SERP landscape where you're paying $5 for 1,000 queries. We want to do, billions of queries a day. That's ultimately the goal. And that's just not tractable unless you're actually trying to organize and, structure the information in a way that reduces that cost. So I can say that, for the hedge funds that we do work with, the cost savings that we're passing on to them is on the order of about 50x to 100x cheaper than, what current search engine providers are able to offer. And it's not just because of the way that we're architecting things. It's also just the way that we've designed the entire search engine. Because my background is a quant, right? What I am passionate about is predicting the future, right? That is what I would like to be able to do. So we've actually architected the entire search engine from the ground up in order to be fit for purpose for that use case. And again, that would not really be possible without, the web access technology, which is oftentimes the hardest part. I'll tell you a funny story, and that's the biggest challenge in building Nosible so far and getting to the point where we've gotten, and we're on track to get to about 10 billion web pages indexed by early next year, has actually just been finding new websites to index, right? And actually going and finding the URLs on those websites themselves. So even though we have the capacity to scale, it's been quite difficult for us to work out where to point that capacity. And it's good to see that there are people in this room and Bright Data as well who are actually working on kind of solving that problem. Cool. Yeah, I've got 10 seconds left. Thank you very much.